Good evening, everyone. Welcome back to Teach Me Now. Even today, we're coming back with another fire video. I hope you all are ready for this video. So our today's topic, guys, it's based on 2D, two dimension. Two dimension, that's grade 11 trigonometry. So without waste time, let's get down to our statement. 7.2. 7.2 in the diagram below. DCB is equals to alpha, right? DCB is equals to alpha. So we have DCB equals to alpha. So meaning now, the alphabet with the cap becomes our actual angle, or the alphabet with the cap is equals to the actual angle given to us. But if you can check something, they gave us three alphabets here, which is D, C, and B. The reason they gave us those three alphabets, they are referring to a certain triangle, which is triangle DCB, right? I hope we understand that part. And then they said AC is equals to H units, okay? And ACB, again, ACB is equals to theta. Again, the angle with the cap becomes our actual angle, or is equals to the actual angle, right? Now, 7.2.1, 7.2.1, determine the size of ACD in terms of theta and alpha. So 7.2.1, ACD equals to, let's go back to our sketch. Our A, here's A, C, and D. So the actual angle that we're looking for C, because the cap is on C. So where is our C according to the triangle ACD, or relative to the triangle ACD? Here's our C there. So how can we find that angle there? We need to say the bigger angle minus the smaller angle. So theta minus alpha, right? So meaning now, our ACD is equals to theta minus alpha. Got your mark. 7.2.1. Now let's go to 7.2.2. Prove that AD is equal to H sine theta minus alpha over cos alpha. 7.2.2. So before we continue, let's check, or rather let's consider angle D1 first. Angle D1, that's the exterior angle. And the exterior angle of a triangle is equals to the sum of the opposite interior angles of the triangle. So those interior opposite angles, we have a 90-degree angle there, and we have alpha as well, right? So meaning D1 is equals to 90 degrees plus alpha. Then now, as from there, now we can proceed with our question. So 90 plus alpha. So now we have what? An angle opposite to our side H, and then an angle opposite to our unknown side. So according to the condition of sine rule, we need to at least look for one unknown, but having side corresponding angle, side corresponding to the unknown side. But now we need to always start with the unknown side, right? Or the unknown on top, rather. So AD divided by sine theta minus alpha, right? Equals to H divided by sine 90 plus alpha. As from here, we cross multiply by sine theta minus alpha. We cross multiply by sine, theta again minus alpha divided by 1. The reason we multiplying everything by sine theta minus alpha, so as to get rid of sine theta minus alpha and isolate AD. Okay, because we're looking for AD. So AD is equals to, now, numerator multiply by a numerator, denominator multiply by a denominator. So h times sine theta minus alpha, that's h sine theta minus alpha. And then sine 90 plus alpha multiplied by 1 stays the same. So we have 90 plus alpha there. And then as from there, according to the cast diagram, we have 0, we have 90, we have 180, we have 270, we have 360 there, né? 90 plus. So here we have, when we go back, we get 90 minus theta. Fourth, when we go forth, we get 90 plus theta. So 90 plus theta or alpha, we get that angle on second quadrant. According to the cast diagram, all students take coffee, right? So sine is positive on quadrant 2. So now, as soon as you have 90 plus something or 90 minus something, the trig ratio changes, right? The trig ratio will forever change. So the trig ratio here is sine. So sine changes to cos. So now we have cos alpha. Proven. We've proven our question. So now let's go back to our question. So now we have 7.2.3. 7.2.3, they said determine the length of AD. So now we're looking for the length of AD. So that's sine theta minus alpha divided by cos alpha. But now they give us the values. So for h, we have 17 sine. They give us 58 for theta, minus 23 for alpha, and cos 23 again. And when we punch our calculator, we get 10,59 units. So 80 is equals to 10,59 units, right? Now 7.2.4. So for 7.2.4, we need to actually find the area of AC or the area of ADC. So for you to find the area of ADC, you need to actually use the conditions of the area rule. But I'll explain the conditions of the area rule now. So for you to find the area of ACD, at least you need to have two sides and an included angle, right? Okay, so they said theta is equals to 58 and then alpha is equals to 23. So 58 minus 23, remember the angle here, we said that's theta minus alpha. So theta minus alpha, that's 58 minus 23, we get 35 degrees, right? And then D1, we said D1, that's 90 plus alpha. So 90 plus 23 gives us 113 degrees, right? So for you to find that angle A there, we need to say 180 degrees minus, okay, that's our A. 180 degrees minus 35 degrees plus 113 degrees. Remember, the angles in a triangle, they add up to 108, right? So 180 minus 35 plus 118, we get 32 degrees. So meaning our A is 32 degrees. At least now we have our angle A. It gave us H as equals to 17. We got AD as 10,59. So we have side, and included angle, right? Now we can use the area rule because we met the conditions of the area rule. So area of triangle ADC the area of triangle ADC is equals to 1/2 side AC multiplied by side AD sine the included angle is what? Our A. Then from there, we need to say 1/2 our AC, that's 17, give us 17, and then our AD, we got 10,59 sine our A, we said that's 32 equals to, and when we punch our calculator, we get 47,70 units squared. So that's the area of triangle ADC. Guys, this is the end of our session, and your tutor from Teach Me Now is signing out.